more into all the properties of the graphs of rational functions. So not just transformations, but what if we have some more complex rational functions? So we have a series of rules for this. We talked about the rational function. We already have that definition kind of written down from the other day, so you probably don't have to write that down again. We know it's just dividing two polynomials. So this is how we find horizontal and vertical asymptotes. Vertical asymptotes are x equals a number where that number makes the denominator 0. So vertical asymptotes, x equals anything that makes the bottom of the fraction 0. You can have more than one of those. For horizontal asymptotes, whether or not or what kind we have, there's actually rules based off degrees. If the top degree is smaller than the bottom degree, it's y equals 0. So I use n and m from my exponents here, but if you could say if the degree on top is smaller, if you prefer that instead of saying n is less than m, I don't care, then it's an automatic y equals 0. If we have the same degree on top and bottom, then it's y equals a over b, or divide the leading coefficients. If the top degree is bigger, there is no horizontal asymptote. Here, why does this work? When we are looking at rational functions, so let's say if I gave you y to the 3 over x plus 4. Can you tell me what's the vertical asymptote of that? What did we say vertical was? X equals whatever makes the denominator 0. What makes the denominator 0? X equals -4. It's kind of like your domain that we did Friday. Domain, the thing that makes the bottom 0, that's where x doesn't exist. That's where we get the vertical asymptote. For the horizontal, if we think about this, it means dividing. So if you do 3 divided by x plus 4, can you do 3 divided by x? No. So it goes into it 0 times. So the horizontal asymptote turns out to be y equals 0. Because the division, it doesn't just equal 0, you have a remainder still, right? It didn't divide evenly. So that's why if the top degree is smaller, if you actually try to divide them, I don't have an x there to divide. It won't work, so your horizontal is 0. Now if it's the same degree, let's say if I make this a 3x. Okay, if you were trying to do long division, that means you would have to do 3x divided by x. Can we do that? What do we get? 3. Okay, and then anything beyond that would be a remainder, right? So it doesn't work out perfectly. We get 3 and then a remainder. So the horizontal asymptote happens at the 3. Because there's a remainder, it doesn't work perfectly, but that's where the 3 comes from. We can get that here if we just divide the leading coefficients. If we see, oh, I have 3x divided by x, that is 3. So that's where the second rule comes in. If it's the same degree, you divide the leading coefficients. The third one says that if the top degree is bigger, then we don't have a horizontal at all. If I said, let's say, 3x squared divided by x plus 4. and you try to divide that. Can you do 3x squared divided by x? Yeah, we get it 3. Okay, and then, sorry, 3x. So we can continue. But right now, once you have an x with this, is it a horizontal line anymore? No. So if the top degree is bigger, if you actually try to divide them, you would get something with variables still, so it's not a horizontal line. Now this one is actually what we would turn out to be what we called an oblique. If I continue doing this division, we have a negative 12x come down. Can you do negative 12x divided by x? Yeah, we get negative 12. And then after that, we could continue, and you would get a remainder, right? So our asymptote, 3x minus 12, isn't that the equation of a line? Yeah. So if the top degree is 1 bigger, when you divide them, you'll have y equals mx plus b, a line. That's an oblique asymptote. So that's the next type. So oblique, when the degree of the numerator is 1 more than the degree of the denominator, we have an oblique. And to find it, we have to do the long division. So pretty much all we're going to do today now is practice finding these asymptotes from equations. The first example is very similar to what we did Friday. I do want to practice just reminding you, if I ask for domain, you're telling me what x can be. That is based off the what? Where do we look to find the domain? The denominator. Yeah. And so it's kind of the same as finding vertical asymptotes. Except the vertical asymptote, you are telling me x equals these. With the domain, you're telling me x can't be these. All right, so we just know that domain, the denominator, can't be 0. So x squared can't be 4, which means x cannot be positive or negative 2. I've told you if it's more than one value, you can leave it like this. If it's just a single value, I expect the interval notation. If you did the interval here, it'd be negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. Can you tell me, where would the vertical asymptotes be here? X equals negative 2, x equals positive 2. The asymptotes are the places where your domain doesn't exist. What if I said x-intercept? Just as practice. How do you find an x-intercept?
Plug 0 in for x.
That would give you the y-intercept. So y-intercept is when your x is 0. If you put in 0 for all of your x's, what do you get?
0, 4, so that's 0.
So your y-intercept is 0. X-intercept is when what? Plug 0 in for the y, which is like that r of x. So it'd be like setting this equal to 0. And what would you get? You would multiply over the bottom. What's 0 times anything? 0. So x and y intercepts are both 0. Just some good things to refresh as we go through here. All right, B. What's the domain? What can x not equal? So our domain would be negative infinity to 1, union 1 to infinity. What if I ask for the x-intercept? How do we find that? Make that f of x equals 0. Okay, if you multiply over the denominator, you would have 0 equals x plus 3, which is negative 3. So the x-intercept is really just what makes the top of the fraction 0. Y-intercept is when all of our x's are 0. So we'd have 3 over negative 1 or negative 3. Okay, so if you need to make yourself a note, the x-intercept, we said that's when y equals 0 on these fractions. It's really just when the numerator is 0. To find a y-intercept, just like with lines, that's when your x's are 0s. So we could do that on any equation that we have to look at. Let's got one more. C. So my domain, we know the bottom can't be 0 for the domain, so we would have to factor that. So we'd factor into x plus 7, x minus 3. So x can't be negative 7 or positive 3. So do you guys feel confident that you could find domains if I asked you to? So let's practice asymptotes. If I asked you to find all of the asymptotes for this. So vertical asymptotes are x equals whatever makes the bottom 0, right? So how would I find that? Just like when we were doing domains. We set the denominator equal to 0. You add 1, divide by 4. Square root plus and minus. So x is positive or negative. The square root of 1/4 is. So we get two vertical asymptotes. X equals negative 1/2. X equals positive 1/2. You have to have the x equals because those are lines. So this would be a graph with two dashed lines. Okay, now for horizontal and oblique. You will never have both of those because they're based off the degree. Remember, horizontal can happen if the top degree is smaller or the same as the bottom. Oblique only happens when the top is one bigger. What is the degree of the numerator? 2. What's the degree of the denominator?
2.
So if it's the same degree, what does that mean?
0.
Yeah, we divide them. If you didn't remember it, you could always think about it and try to do the division. You would set it up as this one divided by that one. Can you do 8x squared divided by 4x squared? Yeah, what does that give us? 2. So our horizontal is y equals 2. And we know that because the degrees are the same, so it tells us all we have to do is divide those leading coefficients. 8 divided by 4. And if it has horizontal, then there is no oblique, so we don't have to do anything else. Can you just look at that and tell me what your vertical asymptote would be?
-4.
X equals -4. Alright, to the side, horizontal or oblique, we look, what's the degree of the top?
1.
And the bottom?
1.
So if it's the same degree, the rule is we divide the leading coefficients. So this is like a 3/1. So y equals 3. Does that make sense? So then another one. So how do we find vertical? Denominator equal to 0. What happens if you do the square root of -1?
Yeah.
I. Can we graph I? So what does that mean about the vertical? None. Horizontal or oblique? Let's see what we've got. What's the degree of the top? 1. What's the degree of the bottom?
2.
Okay. If the top degree is smaller, doesn't even matter how much smaller, if the top is smaller, what's that? Y equals 0. Horizontal, y equals 0. Because if you set up the division, you wouldn't be able to divide it. Could you tell me x and y intercepts in this one if I asked? X-intercept. I told you that's when y is 0, which is really what makes the top of this equal 0.
12.
Y-intercept, if you put in 0 for all of your x's, what do you get? 0 minus 12 over 0 plus 1. So -12/1, what? -12. So x and y intercepts we could do easily as well. Alright, D. Where are we going to have to begin on these? Okay. So if we look at this, we notice, couldn't we take an x out of everything? Yeah, we can take an x out of the bottom. And on the top, you could technically take out an x squared. I'm just going to take out an x to the first for a second so I can show you something. So what happens is those x's cancel. That is what makes a hole in the graph. We will talk more about that tomorrow. When you set that equal to 0, you just get 0. So x equals 0 is actually not going to be a vertical asymptote because it canceled out with the top. It's going to be a hole in our graph. And tomorrow we'll talk more about those. So just know when we're finding the vertical asymptotes, if something reduces, we do have to take that into consideration. It won't be an actual asymptote. So from here, we could then look, the denominator x squared minus x minus 2, that would factor into x minus 2, x plus 1. So the vertical asymptotes would be at x equals 2 and x equals -1. Okay, for the next part, it actually does not matter if we use the original or are reduced. If we look at the original one, what's the degree of the top and the bottom? If we looked here, the degree of the top is 3 and the bottom is 2. Either way, the top is bigger. So that means we can't have a horizontal. Oblique happens if the top is exactly 1 bigger. It is. So to find that asymptote, we are going to do long division. Okay, the good news is we don't have to do the whole long division, just part of it. Again, it won't matter if you do the original or your reduced one. So if I just look at my original, we have a 3x to the 4th. I'm going to go ahead and put in a 0x cubed. Out here. Okay. We are only going to need 2 terms here. We know an oblique is y equals mx plus b. So we basically need the slope and the y-intercept. Okay, so we have to do part of the long division. So it starts out, you're asking yourself, what is 3x to the 4th divided by x cubed?
3x.
Okay. Then we multiply. So 3x times x to the 3rd would be 3x times negative x squared, negative 3x cubed. 3x times negative 2x is negative 6x squared. Does everybody know where I got that line? Okay, so long division. You divide, you multiply, and then we subtract. So the easiest way to do that is to run a negative through all this. So then 3x to the 4th and negative 3x to the 4th cancel. 0x cubed plus 3x cubed is 3x cubed. Negative x squared plus 6x squared is 5x squared. And this is really all we need, because we just need one more term. So we're back to the division step. What is 3x cubed divided by x cubed?
3.
And that's all we need. Because we know the rest of it's just going to give us the remainder. We don't need the remainder. The asymptote is what our quotient is. So it's y equals 3x plus 3. I'm going to put one up here for you guys to try. Are there any questions about how we got that oblique asymptote? Let's check and see if we're on the right track. So it looked like the vertical asymptote was okay. I think it was the oblique that maybe gave you a little trouble. So vertical, we set the denominator equal to 0. So that would factor into x minus 2, x minus 3. So we get 2 vertical asymptotes. X equals positive 2 and x equals positive 3. Everybody get those? All right, so now let's go back and look. What's the degree of the top?
3.
And the bottom? So the top is 1 bigger. What kind of asymptote is that? Oblique. So to get it, we have to do the long division. If it helps you, you can put in zeros for your missing powers of x. So a 0x squared, a 0x. So, first step, divide. What is x cubed divided by x squared? X. Second step, multiply. X times x squared is x cubed. X times negative 5x is negative 5x squared. X times 6 is 6x. Third step, we subtract this off. So x cubed minus x cubed cancels. 0x squared plus 5x squared is 5x squared. 0x minus 6x is negative 6x. So then we divide. What is 5x squared divided by x squared?
5.
So our oblique, that's all we need. Y equals x plus 5. Okay, we're never going to finish the division because we don't need the remainder. Is that one okay? So second one. Vertical asymptote, what makes the bottom 0? So x equals 0. What's the degree of the top? Bottom? So the top is bigger, that means it can't be horizontal, but it's more than one bigger, so that means it can't be oblique. So this one doesn't have horizontal or oblique. It will not have to have all the different types. All right, this is where I'm stopping today. Tomorrow we will start actually drawing graphs, but I want you guys to practice finding the asymptotes and things before we do that. So there is a Math Excel assignment that is open, and you have the rest of the time to work on that.